Alright, welcome back to Chatelier Principle video part 2. Okay, so for today kita akan cover yang the next factors pula. So kita akan tengok the effect of pressure by changing the volume and also the addition of inert gas at a different condition. Okay, so first let's have a look at what is the effect of changing the pressure or the volume of the system. Alright, okay, so change in pressure and volume. So this one, since dia adalah pasal pressure, so it only involve untuk gas sahaja. Okay, just have a look yang dekat bahagian gas sahaja. So liquid and solid are nearly incompressible, therefore kita abaikan je. Okay, that's why dia akan remain constant yang tu. So kita abaikan. So kita tengok sistem yang involve cases components only. Okay, so let's say kita kacau sistem tu. Okay, so if we increase the pressure, meaning what happened to the volume? The volume akan decrease. Okay, so apa yang kita try buat adalah bila pressure increase, okay, bermaksud the system akan try reduce balik the pressure. So untuk reduce balik the pressure, therefore system akan prefer mol yang sikit. Okay, so sekarang ni in order to determine where the system will shift, whether to the right or to the left, dia akan pergi to the side that has a smaller number of mole gaseous punya component sahaja. Okay, so dia akan shift to the side with smaller mole of gas. So depends lah, it might go to the right side, it might go to the left side, depends on the equation. Okay, and then kalau kita decreasekan the pressure, so what's going to happen now is volume pula akan increase. So kalau kita decreasekan the pressure, bermaksud sistem tu akan try naikkan semula the pressure. Okay, so kalau dia nak naikkan semula pressure, bermaksud the system dia akan prefer lagi side yang lagi banyak dia punya number of mole of gas dia. Okay, so untuk ini dia akan system to the side that has a larger number of mole. Okay, mole of gas. Okay, so macam mana sebenarnya benda ni? Okay, let's try and have a look dekat example. Okay, so for example we have PCl3 dengan Cl2 on the left, on the reactant part, and then kita punya PCl5 on the product part. Okay, so kalau kita kira number of mole, tengok dia punya coefficient lah. So on the left side kita ada 2 mole of gas, and then on the right side kita ada 1 mole of gas. Okay, sebab PCl5 ni 1 mole je kan. Okay, so in total sebelah kiri 2 mole, sebelah kanan 1 mole. Alright, so now disturbance dia adalah volume decrease. Okay, so volume decrease bermaksud pressure akan increase. So apa sistem ni try nak buat now? Dia akan try to reduce the pressure. So kalau dia reduce the pressure, bermaksud dia prefer side yang lagi tinggi mole ataupun lagi kecil mole dia. So of course dia akan prefer to the side that has less number of mole then. Okay, so the system dia akan try to reduce the pressure by reducing the number of gas molecule. Okay, meaning dia akan shift to the right then. Okay, because this side ada less number of mole. So what happen is, okay, so since the system will shift to the right, bermaksud the concentration of the product adalah meningkat, meanwhile the concentration of kita punya reactant pula akan menurun. Okay, but then next one, what if volume increase pula? So if volume increase, bermaksud pressure kita rendahkan. So kalau pressure rendah, bermaksud the system will try to increasekan balik the pressure. So kalau kita nak increasekan the pressure, bermaksud the system will prefer to go to the side that has larger number of mole then. So in this particular case, the system will shift to the left then. Okay, so meaning kalau dia shift to the left, so what's going to happen now is the concentration of kita punya reactant akan meningkat. Okay, meanwhile concentration of kita punya produk pula akan menurun. Okay, alright, so do try this one, try this 22. So pause dulu sekejap. Okay, try jawab soalan ni semua, and once kamu dah ada jawapan, okay, you can sambung balik video ni. Okay, misalnya kamu dah post video ni, so the answer for this adalah no effect, left, no shift in equilibrium position, ataupun misterima juga kalau no change. Okay, so no effect dengan no change ada beza sikit lah. Okay, and then E pula ada to the left. Okay, meanwhile try juga ini 23 ni. Okay, pause dulu, pasti Miss akan reveal jawapan. Okay, okay, so Miss harap kamu dah post dah sebenarnya. So the answer for this adalah untuk yang A, the answer is to the right, B to the left, C no change, and D pula adalah to the left. Okay, so let's continue the effect of adding the inert gas into the system pula. Okay, so the total pressure of an equilibrium system can be changed without changing its volume by adding an inert gas. Okay, so the effect of addition of an inert gas to the equilibrium system can be studied based on two conditions. The first one adalah kalau kita tengok addition of inert gas at a constant pressure. Okay, constant pressure bermaksud the total pressure lah. Total pressure tu must remain the same. Okay, it will stay constant. Okay, and then kalau kita satu lagi adalah dekat condition constant volume. Okay, so kita try tengok dulu the addition of inert gas at a constant pressure. So ada dua situasi kat sini kelas. The one on the left side is without inert gas, and the one on the right side adalah bila lepas kita masukkan the inert gas. Okay, so this is the part where kita tambah inert gas at a constant pressure. Okay, at a constant pressure ya. So in this particular case, sistem yang first sebelah kiri ni kita ada gas A, B, C with a different number of mole lah, ada 442. Okay, so given that the P total of the system is 5 atm. Okay, and we know that based on Dalton's law states that the P total is the sum of all the partial pressure of gases yang ada dalam sistem lah. So P total bermaksud adalah partial pressure of A tambah partial pressure B tambah partial pressure C. Kita akan dapat 5 atm. So for example, kalau kita cari partial pressure of A specifically guna Dalton's law, kita akan dapat dia adalah 2 atm lah. So partial pressure A 2, B 2, C 1 dan. Okay, and then what happen next adalah kita kacau sistem tu. So sistem tu kita tambah inert gas. So kita tengok pula situasi yang sebelah kanan ni. Okay, so 1 mole of inert gas kita tambah to the system. Tapi remember, this one adalah at a constant pressure, right? Bermaksud the P total for this particular system still remain 5 atm. Okay, so kalau dia still remain 5 atm, tapi now P total kita adalah bersama dengan PA plus PB plus PC plus P inert. Okay, partial pressure of inert gas sendiri. So keempat-empat ni kita totalkan, kita tetap dapat 5 atm. Okay, and then bila kamu kira the partial pressure of gas A now, as you can see, the gas A now, partial pressure dia adalah 1.82 atm. In comparison to the first one, sebelum kita tambah inert gas, partial pressure adalah 2 atm, partial pressure A. Tapi bila tambah inert gas, partial pressure of kita punya A sekarang dah menurun. Okay, so kalau menurun partial pressure tu, so now the system is no more at equilibrium. Okay, so bila dia dah tak equilibrium, so sekarang ni since pressure turun, so apa yang kita try to buat dekat sistem tu dan? Kita akan try naikkan balik the partial pressure of A dan. Okay, so berlaku perubahan dekat sini dan. Okay, so the total pressure of the system does not change. Kalau ikut yang situasi tadi, 5 atm sebelum kita tambah inert gas, even after kita tambah inert gas pun masih lagi 5 atm. So bila berlakunya addition of the inert gas, what happen is the partial pressure of the gases in the system, they are decreased. Okay, so the addition of inert gas at a constant pressure, it causes the reaction of equilibrium to shift the direction with a greater number of mole of gas. Dan sebab kita try to increase balik pressure kan, sebab partial pressure tadi turun, so kita try increasekan balik pressure, so the system will shift to the side that has a greater number of mole. Lepas ni kita akan tengok contoh lah. Okay, ini contoh dia. So kita guna balik contoh ni. So on the left side kita ada 2 mole, and then on the right side kita ada 1 mole. So by adding noble gas, so what's going to happen to the partial pressure of setiap satu gases yang kita ada kat sini adalah menurun. So that's why kita akan try to increasekan balik the pressure dan. So how, apa yang berlaku dan in order untuk kita achieve equilibrium semula, so dia akan increasekan the number of gas molecule. Bermaksud the system akan shift to the kat mana, side yang mana dia nak pergi, ke kanan, ke kiri ke kanan. So dia kata dia prefer side that has more mole, right? So dia akan shift to the left dan. Okay, so shifting to the left meaning the concentration of kita punya reactant increasing, tapi kita punya product pula akan decrease lah. Okay, so dia akan shift to the left. Okay, so kita boleh nampak concentration ni increase, yang ni pula akan decrease. Okay, okay, so ni satu lagi contoh. Okay, so let's say kita tambah juga kat sistem ni, whereby this system pula both side 2 mole 2 mole. Okay, 2 mole 2 mole. So disturbance dia adalah kita masukkan noble gas dekat situ. Okay, kita masukkan noble gas. So supposedly the partial pressure of kita punya gas kat sini semuanya akan jadi decrease. Okay, so kita akan try untuk naikkan balik the pressure. However, the mole on both sides are the same. So adakah sistem akan shift? No. Okay, dia akan try to shift to the side that has greater number of mole, but since the number of mole are the same on both sides, therefore the equilibrium position is not affected then. So tak ada berlaku shifting tu. It won't shift to the left, it won't shift to the right. So dia akan remain the same je sebenarnya. Okay, so this is the examples untuk yang addition of inert gas at a constant pressure. So now let's have a look dekat another condition. Kalau kita tambah inert gas at a constant volume. Okay, so again sekali lagi Miss guna gas A, B and C. Okay, so let's say kita ada A, B, C as ni. So the P total now is the 10 atm. Okay, 10 atm. So kalau kita kira partial pressure A, B, C ni, kamu akan dapat 4 untuk A, B akan dapat 4 juga, C akan dapat 2. Okay, and then kita tambah inert gas. Tapi keep in mind yang ni adalah dekat a constant volume pula. Okay, so bila kita tambah 1 mole of inert gas, okay, so inert gas ni sendiri dia ada partial pressure dia sendiri lah. Okay, dia ada partial pressure dia sendiri. So the P total now is 11 atm. Okay, so sebab total pressure tak remain constant lah. Okay, bukannya pressure remain constant kat sini. Yang remain constant adalah volume je. Okay, so total pressure akan naik lah bila kita tambah another gas inside. So total pressure now akan increase. So bila kita kira partial pressure of A balik, okay, so partial pressure of A is not affected. Okay, so do you think the system will shift dekat mana-mana side? So in this particular case guys, the addition of inert gas at a constant volume, it will not give any effect then. Okay, because the total number of gases molecule dia akan increase. Okay, but then the total pressure sendiri pun akan increase juga selepas tu. So in terms of the partial pressure of each gases yang ada at the first place, tak affected pun. If at the first place dia adalah 4 atm, lepas tambah inert gas pun it remains 4 atm. So kalau macam tu, it won't shift the system then, bermaksud the system actually still remain at equilibrium. Okay, so the addition of inert gas at constant volume, it has no effect on the equilibrium position then. Okay, oh, settle dah. Okay, so kita settle dah untuk yang the effect of pressure and volume, okay, to the equilibrium system, and also the effect of addition of inert gas into the equilibrium system. Okay, that's it. Bye.